online and see if there's some stuff that might benefit you, especially if it's a difficult section for you. And 4.5 is just a difficult section. 4.3 is a difficult section, okay, because it's got making those equations out of thin air. You got to make this equation. 4.3 is a toughie, okay. 4.5 is a toughie because it's got a lot of theory that you have to nail down. So here we're doing 4.5A, and we're going to start with some points. Now remember, we're talking about what is a, oops, got the wrong little thingies here. These are just points. 5, -2, 4, 1, and 3, 8. So before we start that, just by matter of review, who can tell me what a relation is? We're going to talk about 4 terms here. What is a relation? A set of ordered pairs. Any set of ordered pairs. Now, an ordered pair is a matching up of an X and a Y, of an input and an output. Any set of ordered pairs is a relation, okay? So there's no other rules besides that. The definition of a function. Who's got the definition of a function?
Function of, oh no, it's every x has only one.
Okay, it is a relation, so it's a set of ordered pairs where every x has only one y. So it is very predictable. I think, okay, it's very fair, right? I talked to you about going to the gas station. If I pump 10 gallons of regular gasoline at gas station X, okay, and then somebody comes up behind me and they pump 10 gallons of regular gasoline at station X, they should pay the exact same amount that I do, okay? So that is a function. There are no surprises. For a given X, there's only one Y, okay? So, what is a domain?
The set of all values of the independent variable.
Okay, the independent variable, the input variable, they all mean the same thing, right? Very good. The set of all values of the X, or the independent variable, or the input variable. All right, that is your domain. Where can X live? You think of domicile. Okay, where is my domicile? My domicile is in Niceville, Florida. That's where I live. Okay, so domain, domicile, they have the same root word. Okay, so domain means where X lives. Where can X exist? All right, the range is where Y can live or exist. Okay, so it's all the acceptable values of the Y is the range. So domain is the input, range is the output. Okay, so now let's look at this one. We're looking at a set of ordered pairs, so we know it's a relation. And we're going to see, is it also a function or not? Okay, so what I got to know? Okay, it's not a function because?
X has 2.
Okay, you have a repeat X with different Y's. So anytime you're looking at a set of ordered pairs, if you find a repeated X variable and it does have a different Y variable, then it would be not a function. Now, if this was 3, 0 and this was 3, 0, that would just be a point that was in there twice, and that wouldn't be a problem. But because they have different Y's, it's a problem. It's not a function. Okay, so let's look at another one. We've got -2, 10, 0, 5, 1, 4, 6, -3. Okay, it is a relation because it is a set of ordered pairs. Is it a function?
Yes.
Okay, because I have no repeated X's. Okay, so that, remember we talked about the vertical line test? All right, if I did graph these 2 points, these 2 repeated 3's here, if I were to graph them on a grid, 1, 2, 3, 0 would be there, and 3, 8 would be there right above it. Okay, and remember that vertical line test, if we have a line, and it's really an infinite set of lines, if we have any line that would hit twice as it's sweeping vertically through, not a function. And it only takes one time to mess up, okay? It's like that traffic ticket. You know, you're just going along, you're obeying the speed limit, and then all of a sudden, bam, you forget to look at the speedometer and you get 20 miles over the speed limit. You were going down a hill. You know, it was very easy to do, but bam, you get caught. He didn't care about the, 100 miles that you just went exactly the speed limit. He's going to give you a ticket anyway. All right, so look at this one. This is a line. It has a slope. It has a negative slope. Okay, remember that's going to be on your test. Negative slope, positive slope, zero slope, infinite slope. All of that's going to be on your test. Okay, so this is a line. What is its domain? What is its domain? What can X be? All right, so we can put our little XY grid in there. It doesn't really matter though, because remember, lines go on forever, and so the X can be anything.
So
all right?
Would it be the infinite?
Yeah.
Since it's going down, would it be at negative infinite?
Yeah, well, no, it's still, when you're talking about X, you're talking about this right here, okay? So it is going to go from negative infinity to positive infinity. So if you were going to write that, now remember, you have to be able to write things with both interval and set notation. So if you were going to write this domain in set notation has the variable listed, okay? So the domain would be the set of all X such that, and then you would say X is an element of the real. Okay, so that's set notation for a domain. X is an element of all the real numbers. So that's meaning it goes from negative infinity to positive infinity. If you wrote this same thing with your interval notation, it would be domain is negative infinity to positive infinity. They both say the exact same thing. They're in two different forms. Okay? Notice your interval notation never includes your variable. Okay? Only your set notation includes your variable. So if I were going to say, okay, my domain is the set of all real numbers, isn't my range also the set of all real numbers? Okay, can't my y keep on going? My height of my points is going to keep on going down and up. So I would say my range, now to get to range, all I have to do is change my domain to R, and to change my y. Okay, so I'm going to change my x's to y's, and now I have a good statement for the range. The range is the set of all y's such that y is an element of the real. Okay, that's talking about its infinite state. Okay, there's nothing excluded. And then this one is already good for the range. Just change domain to range, and now we have negative infinity to positive on the range. Okay, now going back to this set, let's go backwards just a minute before we erase this off the board. Okay, going back to this set, what would the domain of this set of ordered pairs be?
3, 4, 5.
Okay, 3, 5, 4, 4, 5, but not another 3. We would not write that other 3 again. Okay, so the set, the domain is just the set 3, 4, 5, 3, 5, 4. Okay, you'll have to look on your Connect Math. I don't think they make you write these in order, but they might. Okay, they might want 3, 4, 5 numerical order. But look at the range of this same set. Okay, because there is a repeated 3, the range has 4 elements. The domain only has 3 elements. Okay, so the range is 0, negative 2, 1, 8. 0, negative 2, 1, 8. Okay? So basically the range is just what can y be? And that's all there is to it. Now let's look at this one. Whoops, where did I put mine? There it is. Okay, and this function is what we call a y-squared parabola. Okay, in fact, it's a negative y-squared parabola. Remember that your parabolas that go up and down, this is a y is x squared, this is a y is negative x squared. Does anybody remember that? Yes.
So basically, the domain is all the possible values of x within a portion of the line or the entire line.
Well, it's the entire line because your line is infinite going on in both directions. So you're talking about what can x be, and you're talking about the whole function.
Okay.
And that function is a line that's going on forever. So that's why you're saying it is any, here you're talking about the range, you're saying nothing is excluded. Every y that is a real y could be used. Okay.
But for that one that you have written right there, where you have the points, is because that it's a line segment. It's only
Yes, and you don't even know that these lie in a straight line. But if you're just given a set of points, even if those points did lie on a straight line, you're not allowed to assume that all of the points in between are included in the function.
Okay.
You're just given 3 points, so you have to just go with what you've got. Okay? So, they will define it as a line if they mean for it to be a line. Okay, they won't ever make you try to jump to that conclusion. All right, so here we have another relation. It is a set of ordered pairs. Is it a function?
No.
No, because remember my vertical line test? I'm going to be popping that thing twice every time I slice it with my vertical line. So this is not a function. Okay, but even though it's not a function, can I still come up with a domain and a range?
Yes.
Okay, my domain is what x can be. And on this one, my domain is what's limited, right? Because I don't have anything out here. Okay, so let's say that this point right here is 3, 0. So x, and remember these are assumed to be going to infinity. Okay, so this is going to be a domain of what? Domain is negative infinity all the way up to 3. Okay, and we're going to assume that 3 is included. And remember, we never put a bracket at the negative infinity or positive infinity. Okay, but what about my range? My range, is there anything limiting how high or how low? Okay, because this is constantly spreading, isn't it? It's going, this arm here is just going to keep on climbing slowly higher. This arm here is going to keep on going down, and it is infinite. So my y is negative infinity to positive infinity. Okay, so I can't have one that's an infinite and one that's limited. If I were going to give you domain and range of this one, okay, this is my facing upward parabola. My y is x squared. It would have some point that it bottoms out. Okay, so if we made that point where it bottomed out 0, 0, then which one's going to be limited here? Okay, my range is limited here. My domain is it's just going to keep on going, right? So my domain would be all real, and that's kind of a cheat. That's not in either form, but it would be what? Set of all x such that x is an element of the real, and the set of all y such that y is an element of the real is not true because it's limited. Sorry, I was getting carried away. Y such that what? Y is greater than or equal to 0 because it is going to be only the positive ones. All right, so let's go ahead. This one is not a function. All lines are function except one type of line. what type of line is not a function? Okay? Vertical. I'm seeing a vertical line. All right? The vertical line is not a function. All other types of lines, even zero slope, is a function. Okay, so let's move on to the next one. And we're going to put a series. And so learning to recognize these and what their shapes are is important. All right, so these are getting a little bit more complicated. That's why I like to work the problems that they give you. And I've got these all on your D2L. Remember, you've got these to print off and look at and ask me questions on. But some of these are things that you haven't seen in that little PowerPoint. Okay, so let's go a little bit more in depth on this. So we're supposed to determine the domain and determine whether it's a function or not. Okay, now I'm going to turn this over this way because I just want to review one function with you. This is a function called the reciprocal function. And the reciprocal function, you want to know this one, okay, because you're going to see some version of it often enough that if you know what it is, you're going to really save yourself some trouble. You don't want to have to graph it every time. You want to know what this looks like. Okay, so this reciprocal function is always going to have a vertical and a horizontal asymptote. Okay, the vertical asymptote is always going to be what makes the denominator go to 0. Bless you. The vertical asymptote is also what limits your domain. Your vertical asymptote, what makes this go to 0, limits your domain. All right, well in this one, if x is 0, we are undefined, right? So x cannot be 0. That is your restriction on the domain. And on the graph, you have an asymptote. An asymptote means a line you cannot touch, okay? So we have an asymptote at x is equal to 0. And this is some equation theory that you will get to a little bit later on, but it does help you to understand why the graph is this way. Y can also not be 0. All right, now try it. If you stuck y as 0 in there, then what would you get? You would get 0 is equal to 1 over x. And if you cross multiplied, which you should be able to do with every equation that works, you end up getting 0 is 1. And 0 does not equal 1. Okay, so that means you can never have a y that is 0. Just won't work. Okay, and the theory behind that, you'll get to a lot of that when you're in college algebra. Okay, but for right now, we want to learn what this thing looks like and what makes it go the domain to be limited. So remember, if I plug in a 1, I get out a 1. If I plug in a 2, I get out a 1/2. If I plug in a 3, I get out a 1/3. So as this line, as my x gets larger, my y decreases, but it never really touches this line. It just gets closer and closer to where you cannot hardly see any space in between. But theoretically, there's never a touching, okay? And then it's going to do the same thing as it goes up this way, approaching but never touching. Okay, now if I plug in a -1, I get out a -1. Okay, and it's going to do the same approaching here. That's your reciprocal function when your x is in the denominator. Yes, sir?
So you just plug in whatever point you want to?
Well, you plug in a couple starting points, but you should know the shape so that you don't have to do a lot of that. Okay, the shape. So basically, if I go to -10, it's going to be -1/10. All right, so that's pretty small. If you go out to -100, it's -1/100. Okay, so it's going to get closer and closer, but it's never going to touch. So now look at that form and look at our equations, and you see that form right there. Okay? So you're going to always have that form on just about every test. They're going to throw this one on. Maybe not every single one, but they're going to like this one in your book and in your Connect Math because it's just one of those famous functions. So here, all right, we know what the normal function looks like. These constants here don't do anything but slide things around just a little bit. The basic shape stays exactly the same. Where we can think of this x is 0 is a hole in our domain, isn't it? So if we were going to write that domain, it would be negative infinity to 0, but not including the 0, union 0 to positive infinity. That's the domain. But over here, what makes this one go to 0 on the denominator? Okay, so we set x minus 4 equals 0 when x is equal to 4. Okay, since I don't want the denominator to go to 0, because that means I'm undefined, I say x should never equal 4, because it makes the denominator go to 0. All right, so now that I've found that point, guess what? I can graph this thing. I'm going to make a little bitty graph. I can graph this thing by leaving the asymptote where the no-touch zone is. So x is 4, cannot be touched. So 1, 2, 3, 4. There's my no-touch line. There's my asymptote. And then guess what's going to happen? It's going to look exactly like this on both sides of that line. So all it does is take the same thing and slide it over. That's all it does. So the shape of the graph is the same. The domain will change by a sliding. Okay? And is this a function or not a function? Is there anywhere that you would pass the line? It's getting closer and closer here. Okay, but it's never touching. So there's no place that you would have a double crossing anywhere. Okay, so this one is also a function. Okay, so this one is a function, and you can know it's a function if you recognize, hey, this is the same thing as my reciprocal graph slid over 4 spaces. Okay, so you want to memorize how this one acts, and it will help you out a lot on the others. Now, this one looks very close, but it's not the same. This one has an X on the top and an X on the bottom. Now, right now, this is something you're going to get into much more in college algebra. You don't need to know how to graph that one right now. You do need to know how to graph this one. Okay, this one's a little bit different. This is a rational function. You don't need to graph it right now, but you do need to be able to find out the domain and whether it's a function. Okay, so if I plug in, what will it make the denominator go to 0? Well, we set the denominator equal to 0 and we solve. So if I want to find out what x can be, I take away the 1 and I take away the 1. And then I get 3x is equal to negative 1, or x is equal to negative 1/3. There's the point that we can't have. Okay, so we're going to have negative 1/3, maybe right there, is going to be my asymptote. Okay, now this one is not going to act exactly the same, but I do need to know that everything else is acceptable. So what would my domain be for this one? Negative infinity up to negative 1/3. Use a little parenthesis. Union 1/3. You're going to use the same point twice. Negative 1/3 twice, all the way to positive infinity. So it's going to be exactly like this, except instead of the zeros, it's going to be negative 1/3. Okay? And is it going to be a function? Is there uniqueness in the output for every single x that you plug in there? Okay? If I plug in an x is 2, all right? Then I'm going to get a 2 over 6 plus 1 is 7. I'm not going to get two different outputs, am I? If I plug in a 2, I've got one thing that can come out of that thing. So, it's a function, even though it looks weird, okay? It is a function, okay? What about this one? Show the top of the board here. Okay, we got to recognize these things. What is this? It's a line. Isn't it in slope-intercept form? Line in slope-intercept form. Since it's a line, and since it has a slope, remember there's only one line that's not a function, vertical. Okay? Since it has a slope, it is a line, it is a function, and it has no limit on its domain. So, negative infinity to positive infinity. Are you done? Okay, where'd you put it? Okay, so give it to me. Thank you so much. Got your name on it?
Yeah.
All right. Thank you. Can you hand me my computer? Thank you.
Yeah.
I'm going to need that in a minute. All right, so now, so this one's a line. What is this? Okay, we just talked about this over here. Recognizing forms, okay? You want to recognize the forms. So this is an x squared parabola. You can tell it's a parabola because one variable is squared and the other one is not. Okay, when we have both of them squared, we get into circles and ellipses and hyperbolas. Okay, but right now, this is what we're dealing with. So this is a parabola facing upward. Okay, since it's a parabola facing upward, is there any restriction on the domain? Continues on negative infinity to positive infinity. Is it a function?
Yes.
You can slice, 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 but never hit it twice in one slice, right? Okay, what's that?
I have a question to the previous one.
This one?
How do you know it's upward?
Because this x squared term is
It's
positive.
Oh.
Okay, so if it's positive, it's upward. If it's negative, it's downward. Both are functions, and both have an infinite domain. It's just which way they're facing. What's this doing?
Ellipse, right?
It's not an ellipse. It's a parabola facing left or right. Parabola facing left or right. How do I know it's a parabola?
Because the y is squared.
Y is squared, but x is not. Okay, if your y is squared, but your x is not, it's a parabola. If your x is squared, but your y is not, it's an upward or downward. Okay, but here, see, you can always tell what these things are going to look like if you take away the constants for just a minute. Just look at your variables. You've got a y squared. Because you've got a y squared, and it's a positive here, it's going to be a right-facing parabola. Okay? Because it's right-facing, every single line is going to hit it twice. It's not a function. Not a function. Now, you have to discover the domain. What can x be? All right? Where? Now let's think about it. Let's just start plugging in some values. If I let y be 0, I get 1 squared. If I let y be negative 1, I get 0 squared. If I let y be negative 2, then I get negative 1 squared. But what's negative 1 squared? 1. Okay? Am I ever going to get a negative x? No. Okay, I'm not going to get a negative x. So this one's going to be, x has to be 0 or greater. Okay, so this domain is what x can be, is going to be 0, and it'll have a bracket, 0 to infinity, paren. Okay? is the domain for that one. Okay, so which one did we leave out? This one. This one is an interesting animal. All right, let's play with this one a little bit because this one is a form that we already have on the board. Okay, now let's do this. I'm going to erase this over here so I have more room to work. Okay, let's look at this form. X, Y is -1. Does anybody recognize it before I show you? What if you solve for Y? What if you just divide by X and divide by X? Y is -1 over X. Does that look familiar? Okay, so it's this one almost, but there's a negative on the front. What happens when there's a negative on the front?
Flip them.
Okay, same shape, still a function, okay? Still has an infinite domain except for 1 point. And that 1 point will still be 0, okay? So this one, for your yes, it is a function, and -infinity to 0, union 0 to +infinity. You're just excluding the one forbidden point, okay? All right, can you see how much theory of equations comes in when you start to deal with functions and domain and range? That's why I wanted to spend a little bit more time on this material, okay? Please, please, please don't forget that all of your homework is due. We're not closing up, so don't close up shop. We're about to do some. But don't forget that all of your homework is due on Thursday. But you want to get all of it done before your test because you need the practice. Okay? Let's go on to the next thing, which is starting to deal with some function notation. Okay? So, function notation, here we've got f of x is 2x minus 5, and g of x is equal to x squared minus 4x plus 3. Okay, so now we're just going to play with these two functions and our function notation. Remember, when we're using our function notation here, we've got the f of x and the g of x are simply taking the place of the y value. So we don't have a y, we have an f of x, which means function in x. X is the input variable, and y is actually the function. All right, so when we're plugging this in, let's just start. What is f of 3? Do these on your paper. I'm going to come back and ask you for the answers in just a minute. So basically, you're going to go back and forth depending on whether you are and I'm going to do these last couple with you because they're a little bit tougher, okay? But you
Okay, I got a question. Why do we just put g over to the g of x? Or does it go with the f of x?
Oh, the g of x is its own function.
I know, but like with the g2 right there.
You're going to just plug in the 2 for the x. So this is saying
2g.
g when x is 2. So it's an evaluation. You're going to plug in 2 into your g function, and you're going to crank out what it equals. Okay? So work on those for just a second.
Wait, what are we trying to find?
You're trying to, this is an evaluation. So this is equal to the f function when you plug 3 in. So it's going to be equal to 2 times 3 minus 5.
Yeah, so we just plug.
You give me the number.
Okay, cool.
So what is 2 times 3 minus 5? So the first one is done for you. Okay, 6 take away 1. Everybody do the other 6. I want to see how many of you can get these correct.
Oh, so it isn't like you're solving for, so 3 isn't the answer to the first one.
No,
3 is.
3 is the input.
That's what I was confused.
You're coming out with the output.
Okay, cool.
All right, who's got the answer to G2? All right, what do you have?
Negative 1.
-1. G2, the right answer. All right, G2 is -1. Okay, does somebody else have an answer for F of -3/4?
3.5.
Okay, did you get that in a fraction form? Because that's not quite right. I'm just wondering if you,
I moved it to decimal form.
okay, but I don't think you had the right fraction before you did that. Check it again. Anybody else got that one? -3/4?
Well, no, I didn't get that answer.
Oh, shoot.
-13/2 is correct. Okay, what would -13/2 be if you did put it in a mixed number or a fraction?
6.5.
Okay, -6.5.
Okay,
Okay, so that would be the same thing. All right, what is F of A? Oops, yeah, what is F of A?
2a minus 5.
2a minus 5, very good. All you're doing is taking the x and replacing it with an a, all right? What is G of K?
K squared minus 4k plus 3.
All right, k squared minus 4k plus 3. All right, so now these two, I'm going to help you out with a little bit.
Wait, can I get my answers first? I think I got these.
All right, so anybody, we have one person answering a whole bunch. I want a few more answering. Is there anybody else that has done F of C minus 3? Okay, because I'm going to do it with you in just a minute. All right, give it to me.
2c minus 11.
2c minus 11 is correct. Good. Has anybody been successful with G of n plus 1? Very good. Very good. So I'll put these up here and then I'm going to do them for you. G of n plus 1 is n squared minus 2n. And I erased my function. F of x was 2x minus 5, and g of x was x squared minus 4x plus 3. When you're doing these, they're a little bit more complicated, but it's the same principle. We're going to take everywhere we see an x, and we're going to substitute a c minus 3. So f of c minus 3 is 2 times c minus 3 minus 5. So here's where I had my x, and I'm going to replace it with c minus 3. So now I distribute and get 2c minus 6 minus 5. Since I have two negatives, it winds up being 2c minus 11. Okay? This one, I'm going to take everywhere I see an x, I'm going to replace it with an n plus 1. So we have a g n plus 1 is x, n plus 1, n plus 1 squared. So where I see the x, I'm going to replace it with an n plus 1. Minus 4 times n plus 1. And then plus 3. So now when I go through and try to simplify, I have to remember how to FOIL, right? Because n plus 1 times n plus 1, we got to FOIL it, right? So we have first is n squared. Outside, all right, so let's put, there's my first. My outsides is n times 1 is n. My inside is 1 times n is n. And my last is 1. And if you do it right, it makes my little favorite Martian guy. Okay, so there he is. If you do it right, you get your little Martian guy. So first, outside, inside, last. That's how you spell FOIL. And when we simplify it, we get n squared plus 2n plus 1. Now that was only one little part here. Okay, so we're not done. So we have this is going to replace this. So we have n squared plus 2n plus 1 replaces this. Take away 4n. I'm distributing. Take away 4 plus 3. Lots of work, okay? So now I have only one n squared term. Remember, we have to add only like terms together. So I've got a 2n and a negative 4n becomes a negative 2. Say what?
Oh, I was just saying negative 2n, sorry.
Okay, so I get a negative 2n, and then I get a 1, take away a 4, plus a 3. But 1 take a 4 is negative 3, plus a 3 is 0. So that is my whole answer. Okay? So, you want to work on those and get those down pat so that you are in good shape. Now remember, your test will be on, let's see, I think I have to let go here, and I moved this. I'm doing all kinds of things trying to get this thing operational because it's my new computer, and I think I moved my dock, but now I don't know where I moved it. Let's see, 4.5. We'll try to get it. And 5.1 there. All right, so right now I found out that I don't even have PowerPoint installed yet. So I will take care of that tonight. But we're going to be able to go over here.
Wait, so
I've got to slide it over here because I've got a backwards screen that I don't want, but we can get there. So yes,
so is this going to be on tonight?
this is not on the test. This is,
No, 5 point or 4.58.
oh yes, I need to stop